Assalamualaikum warahmatullahi wabarakatuh. Okay, now we come to the new topic, which is Fourier transforms. Okay, here we have the definition of Fourier transform. Fourier transform of the function fx equals to the integral of the function of fx exponential to the power of I alpha x dx from negative infinity to infinity equals to f alpha. This is for Fourier transform. And also we have inverse Fourier transform. Inverse Fourier transform of f alpha equals to 1 over 2 pi the integral of f alpha e to the power of negative I alpha x d alpha from negative infinity to infinity equals to the function fx. This is the notation for Fourier transform of function fx. Okay, for example, okay, if we have the function fx equals to u naught if x less than 1 and 0 if x greater or equals to 1. Okay, so for Fourier transform, we have the notation of Fourier transform f x equals to, okay, by using this formula, so we have fx e I alpha x dx from negative infinity to infinity. Okay, then we substitute fx with u0 since our fx is u0. So the integral of u0 e I alpha x dx, and the interval is from negative 1 to 1 since x less than 1, so it should be negative value, and x greater than 1, greater or equals to 1, so we take this as 1. So from negative 1 to 1. Okay, from here u naught we can bring outside, so u naught negative 1 1 e I alpha x dx. So we integrate exponential to the power of I alpha x, we get, so remember you have u naught outside, so we have e to the power of I alpha x over I alpha. Okay, from negative 1 to 1. So we substitute x with negative 1 and 1. So we will get u0 or u naught I alpha e to the power of I alpha minus e to the power of negative I alpha. Okay, the things you have to know is I alpha, exponential to the power of I alpha equals to cos alpha plus I sine alpha, and exponential to the power of negative I alpha equals to cos alpha minus I sine alpha. So we can substitute exponential with this cos alpha plus I sine alpha. So we have u naught over I alpha cos alpha plus I sine alpha minus cos alpha plus I sine alpha. From here we have u0 over I alpha 2I sine alpha. So I here we can cancel. So we get 2 u0 over alpha sine alpha. So this is our f alpha, or Fourier transform of the function fx. So now we have our f alpha. Now the inverse Fourier transform. So we have f inverse f alpha. So f inverse f alpha here. So we have f inverse 2 u0 over alpha sine alpha equals to, by using this formula, 1 over 2 pi the integral of 2 u0 sine alpha over alpha e to the power of negative I alpha x dx from negative infinity to infinity. Okay, 2 here we can cancel. So it's become u naught over alpha, u naught over pi, the integral of sine alpha over alpha. Okay, and here cos I alpha x. Okay, we change to cos alpha x minus I sine alpha x. Okay, from this. Dx. So we can expand this. So we have u naught over pi, here negative infinity to infinity, u naught over pi sine alpha over alpha cos alpha x dx minus I u naught over pi, here negative infinity to infinity, so negative infinity to infinity, sine alpha over alpha sine alpha x dx. Okay, the thing you need to know is sine. Okay, remember the sine always odd function, and alpha also course, here is even. Okay, remember the properties of odd and even function. The product of two odd function is even. Then the product of even function, the two even function is even. So this is odd with odd, so become even. Even multiply with even, so become even function. So this functions is, okay, these terms is even. But here we have sine is odd. Sine here is odd. Alpha also odd. Sine here also odd. So odd, this function odd and odd become even. And even with odd become odd. So this term is odd. Odd. So remember the integral of odd function. So the integral of odd function equals to 0. So we just consider this part. Okay, now we move to the derivatives of Fourier transform. Okay, let's say we have the first order derivative, the Fourier transform of f prime x equals to f prime x ei alpha x dx from negative infinity to infinity. So we can solve this by using this method, and we have negative I alpha f alpha. Okay, this is for first order derivative f prime x. Okay, let's say we have second order, so f double prime x, so equals to negative I alpha square Fourier transformation of the function fx, so equals to negative alpha square f alpha. Okay, this is for second order. Okay, that's all for now. Okay, we will continue the example of wave equation using Fourier transformation later. Okay, thank you.